All right, today we're going to be going over Chapter 3, Section 2, dealing with substitution and elimination. This example, we're going to be working with substitution. In order to substitute, you need to solve for one of the letters. So either I'm going to solve for G or I'm going to solve for H. In this particular case, I'm going to solve for G. I'm going to subtract 3H from both sides so that G, that zeroes out, is equal to 8 minus 3H. So right now I know what G is equal to. Now I'm going to take this information right here, this 8 minus 3H, and I'm going to plug it in wherever I see a G. So instead of 1/3 times G plus an H equals a 9, what am I going to plug in right there? 8 minus 3H. There we go. 8 minus 3H. I'm going to plug that in. Okay? This is the process called substituting. I'm substituting 8 minus 3H for the place of G. Now, we have to distribute. So we're going to distribute both of these. Okay? 1/3 times 8 is 8 over 3. And 1/3 times a negative 3 is negative 3 over 3 times H plus H equals 9. Well, what is negative 3 over 3? Negative H. So we have 8/3 minus an H, because this just simplifies to a 1H, plus an H equals 9. So Zyla was saying right here, these two right here, this negative H and this positive H, they cancel out to nothing. So those zero out. So what are we left with? We're left with 8/3 equals 9. And 8/3 is definitely what? It is definitely not equal to a 9. So here's a situation. Whenever all of your variables cancel out, and you don't have any more variables, no G's, no H's, no X's, no Y's, and it's just one number not equal to another number, then your answer is going to be no solutions. However, let me explain this another scenario. If you had 9 minus H plus H equals 9, if you got to this situation and the H's once again canceled out and it said 9 is equal to a 9, then your answer would be all real numbers. So in this particular case, what happened? The variables canceled out. We had a number not equal to another number. But if, for example, what I said, if you had another number equal to another number, and all the variables cancel out, then that's basically, guys, this is where you have the same line twice. You'll see it says infinitely many solutions. That's where you have the two lines graphed on top of each other. That's infinitely many. What situation did we have up here when it says no solutions? What situation did we have? We had a couple of lines that were what? Parallel to each other. So we had two parallel lines that never crossed. That's what we had. So when you're solving it algebraically, if you have this situation, it's no solutions. If you have this situation, it's all real numbers. Okay? All right, now we're going to work on the elimination method. Okay? This one is a very, very, very easy problem. All you have to do is recognize what we're going to eliminate. In this particular case, I notice I have a positive S and a negative S, which means if I take these two equations together and I add them together, what's going to happen to all the S's? They're going to cancel out to nothing. Bless you. Now we have 2R and we have 3R. And if we add the equations together, that gives us 5R. We add these numbers together, we get 25, and relatively easily, without even having to graph these, we realize that R is equal to 5. That's simple to solve for one of your missing variables. All right, this really works well when you have a what? When you have a positive and a negative. All right, now, This one's not as, now in substitution it's a little easier because you can take some information and plug it back in, okay? What we're going to do here is we're going to take this and substitute it. Now, Sammy, which equation? Do you want the top equation or the second equation? Either one you can use. Top equation? Okay. So what I want you to do, by the way, I can hear, Shayla behind, use the top equation. I like the top equation because it's a little bit easier to work with. There's no negatives, right? So right here, what we're going to do, Leon, we're going to take our R value right here, this 5, and we're going to plug it in for R. I'm trying to make my S's see that they don't look like a 5. Okay? How about I do it over the 3? Okay? Good? All right, she's nodding her head. Good. Now, we're going to plug in our value for R right here. 2 times 5 is 10. 10 plus our S value equals 5. And we're almost done solving for S. What would be the final step to solve for S? Almost. We're going to subtract 10 from both sides to isolate the S. But it's not your fault. You weren't here. You were having to take care of some things, and you weren't here to see that.
That's fine. I'll really end up people.
Well, I'm glad that you didn't.
Yeah,
We're recording.
Well.
There it is.
Okay. That's okay.
All right, 5 minus 10.
-5.
There we go. All right, so now listen. Right here we have a 5 and a -5. Our solution, everybody, is 5, comma, -5. So this was our R value and this was our S value. But if you wanted to, you could put R equals 5 and S equals -5, and either way, however you write it, both those answers I would consider correct. Okay? So if you put them as an ordered pair, that's fine. If you put them as an ordered pair, what I'd like you to do is put it in alphabetical order. Okay? Usually it's X, Y. So right now it'd probably be easier to say R equals this, S equals this. Okay? Now, we're going to go ahead and do number 4 as well. Okay? So put number 4 in your journal, please, and we're going to go ahead and work through this one as well. Yeah, now we're recording. See? Recording. I know. So right now what we're going to do is we're going to look at this problem. Okay? Now notice, if we add these together right here, does anything eliminate out? Ooh, I like that. What we're going to do, all right, Silas said, hey, that's why you multiply the top equation by 2. So what I'm going to do right now is I'm going to erase this line right here, and let's multiply this top equation by a 2, and whatever we get, let's place it right underneath the bottom equation. So we multiply the top equation by a 2, and we get 2 times 2m, which is a 4m. A 2 times a -2, which is a -2n. And a 2 times a -1, which is a -2. I like that method. Because now, if we add these together, look what happens to all of the n's.
Oh, they cancel out.
Yeah. So they totally cancel out to a whole lot of nothing. Now when we add these together, we have 7m plus a 0 equals 30 minus 2, which is a 28. And automatically, without even dividing both sides by 7, you guys can see that m is equal to a 4. Because 7 times 4 is 28. So we just found our value for m. Now, at this point, you have to make a decision. You have to make a decision of where you want to take this 4 and where you want to plug it in. You want to plug it into the second equation or the first equation. You guys make a choice.
Yeah.
Second? All right, second. So I'm going to rewrite the second equation. 3n plus 2n equals 30. And now, we're going to take our value for n that we solved for and plug it in right here. So I'm taking my value for n, and I'm using, right now, what process am I using? I'm using the substitution method right now as far as substituting numbers. And now that we've substituted that, 3 times 4 is 12. So we still have to solve a little bit, don't we? We still have to solve a little bit on this one. So what are the 2 steps that we have to do, Dylan? What's the 2 steps?
First, I have to finish the cereal bar.
First, he has to finish the cereal bar. I can make that happen. All right, so what are the 2 steps here? Bless you. Not bless you, but bless you anyway. All right? All right, you know what? I gave you an opportunity. Thank you, Caitlin. What do we do?
Subtract 12 from
Subtract 12 from both
both sides.
sides. Let me see what we get here. We get 2n equals 18. Then what do we do, Caitlin? That's right. We're going to divide both sides by. Thank you for taking. That's right.
That's your answer.
Correct. So now, our 2 answers are, our n value was equal to 4, and our n value was equal to 9. And those are your 2 answers. Which means, if you ever wanted to take your information, you take the 4 and the 9, and you plug them in right here. All right, so watch. I'm going to clear it out. I want you guys, right here, we're going to plug in a 4, and we're going to plug in a 9, we're going to plug in a 4, and we're going to plug in a 9. And this is how you check to see if your answer is correct. What's 2 times 4? 8. What's 8 minus 9? Negative 1. 3 times 4? 12. 2 times 9? 18. 12 plus 18 is equal to a 30. That's how you can check your answers to see, did I get this right, Mr. DeMoon? What am I going to tell you to do? Plug them in, see if they work. If they work, you're right. If they don't work, you have some more work to do. Okay? All right, one more we're going to do right now on this video. We're going to do number 5. Okay? This is a V. I know it doesn't look like a V, but let's just pretend it's a V. Okay? And what we're going to do is we're going to use the elimination method. By the way, question. Do we want to eliminate the T's or the V's? Which one would you like to eliminate? The V's? Okay. So here's how I would eliminate all the V's. I would take everything and I would multiply it by 2. Let's see what we get, right? We have negative 2t minus 4v equals negative 6. And if I take this other one and put it right underneath it, 2t plus 4v equals positive 6. Interesting. We add these together, I get a 0, 0, and a 0. Which means if 0 is equal to 0, by the way, does everybody agree 0 equals 0? That means our answer is all real numbers, also known as infinitely many. You have infinitely many solutions. Okay? So if you wrote infinitely many or all real numbers, I would totally concur with your reasoning. Okay?
Is your homework